We're continuing our energy unit. Our next investigation is energy transfer, rolling balls down slopes. We will find out what happens when we roll a steel ball down a ramp. We will have two steel balls, one that has a large mass called a large ball, and one that has less mass called a medium ball. In addition to the two steel balls, we will have two ramps. And you can see that they are marked with the 6, 5, 4, 3, 2, and 1. The first thing we will check is if the mass of the ball affects how far it will roll. We will start a medium ball and a large ball at 6 and see which goes further. The second thing we will check is if the mass of the ball affects the speed of the ball. Again, we'll start a medium ball and a large ball at 6 and see which one reaches the cardboard stopping point faster. The first thing we're checking is which ball will go farther. Try number 1, large ball. Try number 2, large ball. The second thing we're checking is which ball is faster, the large ball or the medium ball. Try number 1, large ball. Try number 2, large ball. Very close though. You can see that the heavier ball travels farther than the medium ball, and the heavier ball travels slightly faster than the medium ball. So the next thing we're going to talk about is why does the ball even roll down the ramp? When an object is not moving, the forces acting on the object are balanced. No motion means balanced forces. The motion of the ball on the ramp starts because the forces acting on the ball are unbalanced. The force of Earth's gravity pulls the ball straight down, but the force of the ramp pushes up on the ball at an angle. These unbalanced forces cause the ball to move down the slope of the ramp. I want you to watch the next 3 videos to help explain this.
Is it moving? How could you get the wagon to move? Pushes and pulls are called forces. You can apply a force to the wagon and get it to move. Now the wagon is moving. How might you get it to stop? A push or a pull will bring the wagon to a stop. Remember, pushes and pulls are forces. So to bring the moving wagon to a stop, you need to apply a force. That's the language scientists use. Apply a force. Applying a push or a pull can change the motion of an object. The change can be from no motion to moving, or from moving to no motion. More force in the direction of travel will make the wagon go faster. A small push or pull in opposition to the direction of travel will slow the wagon down a bit. This ball is in motion. How can you change its motion? Speed is a way to describe motion. You can change the motion of a ball by making it move faster or slower. You can apply a force to change the speed of a ball's motion. We can make the ball go faster or slower or stop. What other way can the motion of a ball change? What do you think you will need to do to make the ball change direction? In summary, change of motion of an object is the result of a force applied to the object. Forces cause change of motion. Motion doesn't change by itself. Forces change motion. Motion of an object changes only when a force is applied to the object. Here is another ball sitting on a table. Is it moving? We can apply a force to the ball and move it to the edge of the table. Then what will happen? Why does the ball fall? What caused the change of motion? The ball falls because a force causes it to move downward. Earlier, the wagon and the ball on the ground changed motion because a force was being applied. What force caused the ball to fall from the table to the floor? Gravity is an invisible force that pulls masses toward one another. The force of gravity pulls on the ball, making it move toward Earth's surface. Watch again. This time the ball didn't fall to the ground. It stopped before it got there. What caused the change of motion? The ball is sitting on the table. Gravity is pulling the ball straight down. The table is applying an equally strong force straight upward, so the ball is not moving up, down, or sideways. Now one end of the table is lifted, and the ball starts to roll. The ball's motion changes. What force is causing the ball's motion to change? Because the table is tipped, the table is no longer pushing straight up on the ball. Instead, it is pushing on the side of the ball. Gravity is making the ball move down, but the force applied by the table is changing the direction of the ball's motion. The ball can't go straight down because the force applied by the table is making the ball change direction.
All right, the next thing I want you to think about is, how do you think we could determine if one ball is rolling faster than another? Well, speed is the relationship between two variables, distance and time. That is, how far an object goes in a unit of time. So can you come up with an idea for determining which ball is traveling faster in a ball and ramp system? So we'll use two ramps, two large steel balls, a tape measure, and tape. So I want you to think about those different items and what we could do to set up a system. And I want you to send me your ideas on Seesaw or email. And then on Thursday, we will design a system and attempt to answer the focus question. And the focus question is, how does the starting position affect the speed of a ball rolling down a ramp?